Physics problem bonus mark 3. Right. So for this problem, we've been asked to consider a two-dimensional case of a uniform right-angle triangle sheet of mass, M and height h with base b. The thickness may be neglected. Now, for part A, we're asked to determine mathematically a vector that identifies the center of mass of this sheet in terms of h and b, and to show and discuss your mathematical reasonings. So the question asks us to find the vector that identifies the center of mass in terms of h and b. So I started out by drawing a diagram, which made it a bit clearer. So the triangle is drawn at the origin, up to 0h, and its third point is at B0. Now I've also marked in the midpoints of each of the lines. So 0h divided by h on 2, b on 2, h on 2, and b on 2, 0. With our x and y axis. Now, the center of mass is an average position of all points of the mass within a system. This occurs at the intersections of a triangle's medians. So, from that, we can gather that if we draw a line from each corner to the opposite midpoint, we'll be able to find the center of mass. And here we've found it just by eye. So, now to work out where this is, this occurs where there's an intersection of all three lines. So, if we take the line from 0h on 2, so 0h on 2 down to B0, and the line 0, 0 to B on 2, h on 2, we'll be able to find the intersection points, and that'll give us our value of C here. So, start off, we'll go 0, we'll find the line of 0, h on 2 to B0. Now, our gradient, or M, is equal to minus h2b over 2b, and therefore our y is equal to, our equation for the line is y is equal to minus h over 2b x plus c. Now if we sub in x is equal to b and y is equal to 0, so that's our other point, we find that c is equal to h on b. Now if we follow that down, then we use our c value, we find y is equal to minus h over 2b x plus h over b. And we'll simplify that down. We get 2b equals minus hx plus hb, and hx plus 2b is equal to hb. And that's our first equation there, so number 1. Now, if we take the line 0, 0 to b on 2, h on 2, we find, so we're doing b on 2, h on 2 to 0, 0. We'll find that our gradient is m equal to h on b. So, now we can take that value there, and we're going to get h is equal to h on b x plus c. Now this line goes through the origin, so we can sub in x equals 0, y equals 0, and that's going to give us y is equal to h on b x, as c is equal to 0 there. Now, this leaves us with, finally, the equation by equals hx, and that's our second equation. Now, we're going to use this equation here, 2, to substitute into 1, to find what our x and y values are. So we finished up here with equation 1, hx plus 2by equals hb, and we're going to let by equal hx. So we've got hx plus 2hx equals hb, x equals b on 3, and then we also have here by plus 2by equals h on k, so our y value is equal to h on 3. Now, therefore, our center of mass is at b on 3, h on 3. Now, in vector form, this is b over 3 I plus h on 3 j. So, with that in mind, we can then take our cardboard cutouts, because in part B, we're asked to represent this using string and a model. And we can see here, our cardboard is flat. Now we can also do this with a non-right angle triangle. Using a similar principle, we'll be able to see that this one indeed also is flat. Dog-eat corner. So when finding the center of mass of a non-right angle triangle, you go from the angle across to the midpoint on the opposite side again, and just do it all the way around. Thanks for listening.